No one saw this coming. Not Elon Musk, not Wall Street, not the trillion-dollar electric vehicle industry, but somewhere deep inside Toyota's secretive research and development labs. It just happened, something that wasn't supposed to leak, something that could wipe out the very foundation of electric vehicle dominance overnight. No press conference, no flashy reveal, just a quiet demonstration behind closed doors in Aichi, Japan. A single prototype, no battery, no gasoline, no hydrogen tank, just water. And within 48 hours, the shockwave had already begun. $17 billion in electric vehicle stock value gone. Tesla staggered, Rivian plunged, Panasonic went red. Because what Toyota's CEO allegedly unveiled isn't just a new engine, it's a direct threat to everything the electric revolution was built on. Rainwater, tap water, even seawater. The car doesn't store hydrogen, it makes it on the fly as it drives. No rare earths, no superchargers, no lithium, just a steady chemical reaction that rewrites every rule. Sources inside the room described the moment as surreal. One executive stood in stunned silence. Another broke decades of protocol and applauded for 6 minutes straight. And for Japan's famously stoic boardrooms, that's not excitement. That's a seismic event. Because if this tech is real, and early leaks say it is, then the future doesn't belong to batteries, it belongs to water. So before this gets buried, before the lobbyists scramble to shut it down, hit that like button, subscribe, and stay with us. Because what you're about to hear may be the beginning of the end for electric cars. Forget everything you thought you knew about hydrogen. This isn't the Mirai 2.0. That car used fuel cells, a separate tank, and complex pressurization. It was clean, yes, but expensive and limited by infrastructure. This new engine isn't that. This is combustion. Toyota has figured out how to burn hydrogen directly inside an internal combustion engine using a modified chamber that can handle temperatures above 2,000 degrees Celsius. The result, a roaring high-performance engine that produces only one byproduct, steam. But here's the truly radical part. The engine doesn't store hydrogen, it makes it. Using a proprietary nanocatalyst and a piezoelectric separation system, the vehicle extracts hydrogen atoms from water molecules in real time. That's right, while driving. You pour in water and the car splits the H2O on demand, burns the hydrogen and exhausts nothing but mist. How much water does it use? Well, it's around 5 liters per 100 kilometers. No battery fires, no grid overload, no rare earth metals, just water. And yes, Toyota says that includes salt water. There's no need for ultra-pure lab fluid. You could, in theory, refill from a rain barrel or even a river. So why haven't we heard about this until now? Because this engine is not new. In fact, Toyota started building it 17 years ago under a top-secret program called Project H2X. The idea was sparked in 2008, right as the world's focus shifted to lithium-ion batteries. Toyota was already a leader in hybrids with the Prius, but they saw something others missed, the coming limitations of battery tech. So, they began working in silence on a combustion alternative, one that didn't rely on mining, charging, or cobalt supply chains. By 2012, Project H2X had working prototypes, but suddenly it vanished. No press release, no funeral, no leaks, just silence. Insiders claim it wasn't technical failure that killed it. It was pressure from oil companies, lithium lobbyists, and even their own hybrid partners. EV startups were gaining momentum, and honestly, a water engine would have threatened way too many existing interests. So, Toyota shelved it. The engineers were reassigned, many to the more politically palatable Mirai project. Hydrogen fuel cells were seen as safer, more manageable, easier to regulate, and yeah, just easier to control. But the world changed. By 2024, headlines were filled with EV battery fires, power grids buckled under charging demand, lithium mining scandals erupted across Africa and South America, and suddenly, Toyota's board saw something they hadn't seen in a decade, an opportunity. Project H2X was revived in early 2025, and this time they weren't starting from scratch. They dug up the prototypes, 3 vehicles locked away in a temperature-controlled vault in Aichi Prefecture. Updated with modern components, the new testbed hit the road within 5 months, and what it delivered shocked even the engineers who built it. The vehicle accelerates from 0 to 60 in 4.3 seconds, which is actually faster than a Prius Prime and really on par with a lot of electric vehicles out there. Its top speed is 180 kilometers per hour with no torque drop on uphill climbs. And get this, the range is a jaw-dropping 760 kilometers on a single 50-liter water fill. And the refueling process. Well, there's no $2 million hydrogen station, no electric charger, just a garden hose. You connect it to the onboard port, flip a switch, and in less than 3 minutes the tank is full. And unlike electric vehicles, you don't need to wait hours for a recharge. There's no range anxiety. There's no battery degradation over time. Even more shocking, maintenance is simpler than on a gasoline engine. Toyota's engineers claim wear and tear rates are 42% lower than comparable combustion engines. Why? Because water vapor is the only exhaust. There's no carbon buildup, no soot, and significantly less heat stress on internal components. What started as a buried science project from the 2000s may now be the biggest existential threat the EV industry has ever faced. And, what happens next could send shockwaves through every car maker, every miner, every battery startup on Earth. Because the moment this hits mass production, everything changes. And as of this moment, Toyota has already begun internal testing on multiple production-ready variants. No one was ready for the tremor Toyota sent through the electric vehicle world, not even Tesla. Because if what's in this engine is real, then the entire EV supply chain, the lifeline of an industry worth over $1 trillion, just got hit by a silent, invisible tsunami. Inside Tesla's Giga Nevada, panic quietly set in. Battery modules, once seen as the core of sustainable transportation, were suddenly obsolete, lithium no longer needed, cobalt and nickel irrelevant. That $4 billion Panasonic battery plant in Kansas, a ticking time bomb of stranded capital. Executives from Lucid Rivian, and even legacy titans like GM, were reportedly summoned into closed-door meetings less than 24 hours after the prototype leak. The whispers were the same in every boardroom. If this water engine is real, we're done. It wasn't just the materials, it was the infrastructure. Thousands of charging stations across the US, the entire supercharger network, rendered unnecessary. Recycling startups that bet their futures on dead lithium cells were already slashing staff. They saw the writing on the wall. You don't recycle what you don't use. And just as the industry began to comprehend the technological quake, the numbers started trickling in. This wasn't some sci-fi prototype requiring rare earth elements and platinum-lined fuel cells. The total engine cost, $1,320, less than 1/3 the cost of a standard EV drivetrain. No onboard battery banks, no high-voltage inverters, just a small water tank, a hydrogen separator, a piezoelectric converter, and a supercapacitor the size of a lunchbox. The operating cost, a staggering 0.8 cents per mile. That's not a typo. Compare that to the 3.2 cents per mile for most EVs, already far cheaper than gas, and the economics just went nuclear, even factoring in full vehicle production and energy sourcing. The lifetime emissions of this water-powered car came in 78% lower than the greenest Tesla, including manufacturing. And then came the kicker break-even point, 1.4 years. That's how fast an average user would recover the entire premium through fuel savings. After that, it's nearly free transportation indefinitely. So, what kind of magic was buried inside this thing? At its core is something engineers once called impossible, a piezoelectric ultrasonicator. Using high-frequency mechanical vibrations, it splits water molecules instantly into hydrogen and oxygen on demand. Not stored, not compressed, not explosive. The hydrogen feeds a small combustion chamber while oxygen is expelled or reabsorbed. The energy is buffered not by a lithium-ion pack but by a dense supercapacitor array that stabilizes current and recharges from the car's own kinetic motion. Cold start verified at minus 22 degrees Celsius, meaning it works in winter. Emissions lab verified trace oxygen and water droplets. That's it. No NOx, no carbon dioxide, no smog. The tailpipe steam on a cold morning is the only clue that anything is even running. And perhaps most critically, there's no hydrogen tank, no compression, no fire risk. The engine generates what it needs as it drives, like a portable power plant that